Welcome to aminacademy.com. In fluid mechanics, let us discuss about types of fluids. The fluids may be classified into following 5 types. First one, ideal fluid. Second one, real fluid. Third, Newtonian fluid. Fourth one, non-Newtonian fluid. And fifth one is ideal plastic fluid. Look at this figure here. This in xy axis, in x axis it represent velocity gradient, that is du by dy, and y axis represent shear stress eta. Now that 5 fluids are graphed here. First one, ideal fluid. A fluid which is incompressible and is having no viscosity is known as an ideal fluid. Ideal fluid is only an imaginary fluid. As well all the fluids which exist have some viscosity. There is no fluid without viscosity. Now ideal fluid is an imaginary fluid, means it's incompressible and no viscosity. So ideal fluid is imaginary fluid. So it represents in x-axis. Now second one, real fluid. A fluid which possesses viscosity is known as real fluid. All the fluids in actual practice are real fluid. Here, having viscosity, now most of all fluids is represented real fluid. Here, the real fluid next, third one, this is a real fluid is a Newtonian fluid. So third one is Newtonian fluid. Newtonian a real fluid in which the shear stress is directly proportional to the rate of shear strain or viscosity gradient is known as Newtonian fluid. Means it obeys Newton's law of viscosity. Therefore here Newtonian fluid, shear stress is directly proportional to rate of shear strain. Rate of shear strain. In Newtonian fluid, shear stress is directly proportional to rate of shear strain. Fourth one, non-Newtonian fluid. A real fluid in which the shear stress is not proportional to the rate of shear strain or velocity gradient is known as non-Newtonian fluid. Means shear stress is not proportional to the shear strain. Fifth one, ideal fluid, ideal plastic fluid, ideal in which shear stress is more than the yield value and shear stress is proportional to the rate of shear strain, means velocity gradient is known as ideal plastic fluid. Means shear stress is than more than the yield value and shear stress, and also shear stress is proportional to the rate of shear strain. Here these all five fluids is noted in XY diagram. We have done. Please subscribe our YouTube channel.